What if the scariest solution to the Fermi paradox isn't that we're alone, but that we're contained? The zoo hypothesis suggests the galaxy could be teeming with intelligence watching, waiting, and strictly enforcing our isolation. But this isn't a story about UFO sightings or blurry lights in the sky. This is an audit, a forensic scan for the one thing no civilization can erase, only manage waste heat. Because energy usage leaves fingerprints, infrared receipts, thermodynamic debt. Yet when we search the stars for these signatures, we find almost nothing above our current detection thresholds. The dataset is suspiciously clean, so we have to ask, is the universe empty? Or has it been engineered to look that way? Before we accuse the universe of being empty or engineered, we need a baseline. To understand the severity of this silence, we must first examine the timeline. The universe is approximately 13.8 billion years old, yet Earth is a relative newcomer at just 4.5 billion years. This gap creates a massive discrepancy. If a civilization had emerged just 1 billion years before us, a mere rounding error in cosmic time, they would have had ample opportunity to expand. Even with sublight propulsion, many models suggest a determined species could spread across the Milky Way on timescales of tens of millions of years. On a geological scale, that is the blink of an eye. By all logic, the galaxy should be saturated with their infrastructure. So why isn't it to answer that we must audit the evidence we actually have, not the evidence we hope for? First, there is evidence. A radio silence. For decades, SETI has pointed dishes at the stars, listening for a broadcast. We hear nothing but static. However, in forensic terms, this is weak evidence. Radio waves attenuate over distance. Civilizations might use tight beam lasers, neutrinos, or fiber optics. They might simply choose not to broadcast. Radio silence implies discretion, not absence. The true anomaly lies in evidence B waste heat. This is the physical byproduct of work. A civilization advanced enough to span stars requires energy, lots of it. And according to the laws of thermodynamics, that energy used must leave a thermal footprint. You can choose to stop talking, but you cannot choose to stop radiating heat. This is where the investigation turns dark, because if we can't hear their voices, that might just mean they are quiet. But if we can't see their heat, that changes the nature of the case entirely. Physics has a rule, and it's the strictest statute in the universe. You can't erase entropy. You can only move it. To understand why the silence is so suspicious, we have to look at the energy budget of a civilization. Any society that advances beyond its home planet is essentially an energy processing engine. They harvest starlight, they build structures, and most importantly, they compute. Whether they are running biological brains or silicon supercomputers, the act of processing information is not free. According to the Landauer principle, erasing a single bit of information releases a minimum amount of heat, specifically K sub B times T times ln 2 joules. This seems negligible on the scale of a microchip, but scale it up to a civilization spanning a solar system, processing astronomical amounts of information, and the thermodynamics become undeniable. Entropy is a debt collector. You can perform work, you can build starships, and you can construct utopias, but eventually the debt must be paid in waste heat. This is why the search for extraterrestrial intelligence, or SETI, isn't just about listening for radio signals. Radio is voluntary. A civilization can choose to turn off its transmitters, but heat is involuntary. According to thermodynamics, any system doing sustained work must dump waste heat, and by the Stefan Boltzmann law, that heat has to be radiated away often in the infrared. Imagine a Dyson Sphere, a megastructure built around a star, to harvest its energy. Even if the builders surround the star and capture most of its output to run their machines, that energy doesn't disappear. It is degraded. It flows through their computers and habitats and eventually radiates outward as infrared heat. To a thermal camera, a Dyson Sphere wouldn't look dark. It would glow like a massive ember in the deep infrared. Therefore, a galaxy teeming with advanced civilizations shouldn't look like a collection of pristine stars. It should look infrared bright. It should be filled with stars that have been dimmed in the visible spectrum, but are blazing bright in the infrared, evidence of their energy being metabolized by intelligent life. We aren't looking for a needle in a haystack. We are looking for a forest fire at night. So we ran the biggest thermal audit in human history, and the result was unsettling. In 2014, a team led by astronomer Jason Wright launched the GHAT survey, short for Glimpsing Heat, from Alien Technologies. They didn't rely on HOPE or lucky radio intercepts. They used hard data from NASA's WISE satellite, short for the Wide Field Infrared Survey Explorer, to scan the thermodynamic signatures of the cosmos. The scope of the audit was massive. The team examined approximately 100,000 galaxies. They were looking for K-type, the three civilizations empires so vast they had colonized their entire host galaxies and were repurposing a significant fraction of the starlight for their own use. If the universe follows a natural progression of expansion and consumption, these galactic empires should be the loudest things in the sky. The results of the audit were stark. Out of 100,000 galaxies scanned, the number of civilizations found repurposing more than 85% of their galaxy's starlight was zero. The forensic team found about 50 candidates that showed unusually high levels of mid-infrared radiation, a potential signature of partial colonization repurposing roughly 50% of a galaxy's starlight. However, subsequent analysis suggested that even these anomalies had plausible natural alibis, mostly dense dust clouds from fervent star formation or interactions within the galaxies themselves. This finding places a severe constraint on our models. It sets an upper limit on the prevalence of loud civilizations. It tells us that the universe is not filled with voracious expansionist empires that consume stars with reckless abandon. If they were there operating at maximum efficiency, GHAT would have seen them. Their energy budget would have left a thermal signature too large to miss. This leaves us with a forensic dilemma. We have a timescale that suggests the galaxy should be colonized and a thermal audit that says it is pristine. This discrepancy leads to two conclusions. The first is the graveyard hypothesis, that intelligent life is incredibly rare or inevitably destroys itself before it can expand. But the second conclusion is far more unnerving for a detective. Perhaps they are there. Perhaps they are everywhere. But they are not loud. They are operating under a strict low-emission regime. Either the galaxy is dead, or someone has learned how to hide a bonfire in plain sight. Hiding a star-scale civilization is extremely hard, unless you can manage exactly where the heat goes. If we take the GHAT results seriously, they suggest the universe isn't full of maximalist galaxy-spanning empires burning through starlight. That leaves us with a fascinating engineering alternative. Perhaps advanced civilizations do not optimize for expansion. Perhaps they optimize for efficiency. In forensic terms, they might be operating under a low-emission regime. To understand how this works, we must look at a concept proposed by Robert Bradbury in 1997, the Matrioshka Brain. Named after the nesting Russian dolls, a Matrioshka Brain is a megastructure that takes the Dyson Sphere concept to its ultimate thermodynamic conclusion. Instead of a single shell collecting energy, imagine a series of concentric shells nested inside one another, effectively surrounding a star. The physics of this structure is an exercise in extreme recycling. The innermost shell surrounds the star and absorbs its raw, high-intensity energy. It uses this energy to perform computation running simulations, maintaining digital consciousness, or processing data. As we know from Landauer's principle, this work generates waste heat. In a standard Dyson model, this heat is dumped into space, creating the infrared beacon that GHAT failed to find. But in a Matrioshka Brain, that waste heat isn't discarded. It becomes the fuel source for the next shell. The second shell absorbs the infrared radiation from the first, uses it for lower energy computations, and radiates its own even cooler waste heat to the third shell. This cascade continues through layer after layer. With each step, the energy is degraded, the frequency drops, and the temperature falls. By the time the energy reaches the outermost shell, the exhaust has been squeezed of almost all its utility. The final layer radiates the remaining entropy into deep space, but not as a blazing infrared signal. In the extreme limit, the outer shell could in principle radiate at temperatures asymptotically close to the cosmic microwave background, about 2.7 Kelvin. If a civilization could achieve this, they could become effectively invisible to our current surveys. They would absorb the blinding light of their host star and emit nothing but a faint, cold whisper that blends indistinguishably with the background noise of the Big Bang. They wouldn't be a lighthouse, they would be a vantablack forest, an object so efficient at trapping energy that it becomes an infrared void. However, physics demands a price for this invisibility. The Stefan-Boltzmann law P equals a sigma T to the fourth dictates that as the temperature T of your radiator drops the surface area A required to radiate the same amount of power, P must increase exponentially. To hide a star like our Sun and emit waste heat at near CMB temperatures, the outermost shell of a Matrioshka brain would need to be astronomically large, likely extending hundreds to thousands of astronomical units well beyond the outer planets into the deep outskirts of the system. The material cost to build such a radiator is staggering. It would require dismantling not just planets, but entire solar systems worth of mass. This brings us to a critical forensic discrepancy. We are looking at a mechanism that is theoretically possible, but economically insane. Why would a civilization spend the energy equivalent of 1,000,000 years just to build a shell that hides them? Why cripple their own expansion to live inside a cold, dark cage unless the cage isn't a prison, unless it is a bunker? But here's the real question. Why would anyone pay that cost? Thermodynamics tells us how they might hide, but game theory tells us why. If we assume that intelligence is common, but the universe is silent, we must consider the possibility that silence is a selected trait. In evolutionary biology, animals that make too much noise get eaten. In cosmic sociology, this is known as the dark forest theory. Popularized by sci-fi author Lou Cixin, but rooted in serious game theory analysis, the dark forest hypothesis suggests that the universe is not a harmonious community. It is a zero-sum game played with relativistic weapons. Consider the strategic landscape chain of suspicion. You cannot know the true intentions of another civilization. They might be benevolent today, but aggressive tomorrow. Technological explosion at civilization. A might be primitive now, but due to exponential technological growth, they could surpass and threaten civilization B in a cosmic blink of an eye. First strike advantage. In a universe where weapons can travel at near light speed like relativistic kill vehicles, there is no defense. You cannot block a rock the size of a bus moving at 99% of the speed of light. The only defense is to destroy the potential threat before they destroy you. In this environment, the most rational strategy for survival is not communication. It is stealth. If this logic holds, then the Matrioshka brain isn't just a computer. It is camouflage armor. The immense cost of building a vantablack structure is justified because it is the only thing preventing extermination. Furthermore, there are other speculative mechanisms for hiding waste heat that align with this paranoia. A civilization might employ directed waste heat. Instead of radiating entropy in all directions through isotropic emission, they might use high-powered infrared lasers to beam their waste heat into the empty voids between galaxies toward directions where they calculate no observers exist. From our perspective on Earth looking at such a star, we would see nothing. The star would appear to have vanished, its light blocked by the Dyson swarm, and its heat vented away from us. We would simply see a gap in the star field. This reframes the entire zoo hypothesis. We used to think we were in a zoo because they were benevolent keepers protecting us from ourselves. But the dark forest suggests a chilling alternative. They aren't enforcing a quarantine to protect us. They are hiding in the dark, trembling, holding their breath. They aren't talking to us because speaking reveals their coordinates to the hunters' apex civilizations that patrol the galaxy looking for thermal signatures to extinguish. The silence of the universe isn't a peace treaty. It is a tactical blackout. And we, in our naivety, are currently building bigger radios and brighter beacons shouting hello into a forest where everyone else is armed and silent. If silence is armor, then what exactly are they hiding from? And more importantly, are we standing in the crossfire? If the galaxy is a forest, maybe the fence isn't out there. Maybe it's right here. The biggest problem with the dark forest or zoo models is the speed of light. If a warden civilization is observing us from a star system 1,000 light-years away, they are watching the Roman Empire, not the 21st century. By the time they see us detonate an atomic bomb and decide to intervene, their cease and desist order will arrive 1,000 years too late. For any containment protocol to be effective, the monitoring must be local. It must be real-time. This leads us to the concept of the Bracewell probe. Proposed by physicist Ronald Bracewell in 1960, these serve as the autonomous sentinels of the galaxy. Instead of broadcasting signals into the void, an advanced civilization would send automated probes to candidate star systems. These devices would enter a parking orbit powered down and simply listen. They are the hidden cameras in the trees, waiting for the animals to figure out how to use fire. But where would you hide a sentinel in a solar system as cluttered as ours? You wouldn't put it on the moon. It's too exposed. You would put it where physics provides a natural camouflage. We should be auditing Lagrange regions, especially stable niches, like Earth-Moon L4, L5, and long-lived co-orbital corridors. These are regions in space where the gravitational pull of the Earth and the Sun balance out, creating semi-stable regions, where an object can remain in a long-lived configuration, often with minimal station keeping. These are the parking spots of the solar system. If a probe arrived here 1,000,000 years ago, it could still be sitting there today, disguised as one of the thousands of Trojan asteroids that naturally accumulate in these gravitational traps. To a telescope, a dormant, dust-covered probe looks exactly like a rock. And that's the worst part. Even if a probe is here, we might not recognize it. We have already encountered objects that demonstrate just how blurry the line is between natural debris and artificial artifact. Consider the case of 1991. VG. Discovered in November 1991 by the Spacewatch telescope, this small object, roughly 10 meters across, presented a forensic nightmare. Its orbit was suspiciously similar to Earth's, and it exhibited rapid brightness fluctuations, suggesting it might be a rotating metal fuselage rather than a rock. For a brief moment, the SETI community held its breath. Was this a Bracewell probe? Further analysis provided a more mundane yet equally artificial explanation. It was likely a spent rocket booster from an Apollo-era mission drifting back home after decades in the void. However, the 1991 VG incident serves as a crucial demonstration of our forensic blindness. We barely have the capability to distinguish a piece of our own trash from an asteroid. A hyper-advanced alien probe designed with stealth technology or simply programmed to remain inert and cold would be effectively invisible to us. We assume that if they were here, they would land on the White House lawn. But an efficient auditor wouldn't reveal itself. It would sit in a co-orbital trajectory, disguised as a quasi-satellite, like Kama'olewa, passively collecting our radio leakage, our radar emissions, and the unmistakable signatures of an industrial planet. It wouldn't act, it wouldn't signal, until a specific criterion is met. This shifts our perspective from curiosity to operational alertness. We have spent 60 years assuming we are the ones doing the searching. But the logic of containment suggests the opposite. We aren't the hunters. We are the subjects, and we are rapidly approaching the moment where the subject looks back at the camera, because the next thing a hidden probe might detect is us detecting it. Are finally changing the answers we can test. For the last 60 years, humanity has been the quiet kid in the back of the class cup pressed against the wall, hoping to hear a whisper. This was the era of Radio SETI. It relied entirely on the hope that someone somewhere was trying to talk to us. That era is ending. We are now entering the era of atmospheric forensics. We are building a new generation of floodlights telescopes so powerful they can infer atmospheric chemistry from light reading the spectral fingerprints of planets dozens of light years away. The James Webb Space Telescope, or JWST, has already begun this work by characterizing the atmospheres of gas giants. But the real game changer arrives later this decade, the Extremely Large Telescope, or ELT. With a 39-meter primary mirror, the ELT will gather vastly more light than any telescope before it, pushing spectroscopy and direct imaging into a new regime. It will push us closer to directly imaging rocky exoplanets around nearby stars, especially the best closest targets. We will no longer need them to transmit a radio signal. We won't need them to build a Dyson Sphere. We don't need them to speak. We just need them to leave a chemical footprint, something nature wouldn't write by accident. We're not looking for alien faces. We're looking for industrial chemistry. Biology produces oxygen and methane. Finding those would be monumental, a biosignature. But to confirm a civilization, to confirm we are in a zoo rather than a nature preserve, we need a technosignature. We are hunting for molecules that nature doesn't know how to make. The smoking guns of industry. Forensic astronomers have already identified the prime suspects: chlorofluorocarbons, CFCs, nitrogen dioxide, NO2, and sulfur hexafluoride, SF6. On Earth, SF6 is a potent greenhouse gas used in high-voltage electrical switchgear. It does not exist in nature. If we point the ELT at a planet 50 light-years away and detect the spectral fingerprint of SF6 or CFC12, the ambiguity vanishes. These are low false positive signals. Volcanoes don't burp out freon. Swamps don't emit industrial electrical insulators. Finding these gases would be a high-confidence indicator of a technological society, one that is burning fuel-cooling buildings and generating electricity just like us. This brings us to the information threshold. Within the next 20 to 30 years, humanity will cross a line. We will possess the observational capacity to strip away the anonymity of our stellar neighbors. If there is a civilization hiding in the Vantablack forest, managing their heat and keeping their radio silent, our new floodlights might just catch the reflection off their solar panels or the chemical exhaust of their factories. This is the jailbreak. We aren't breaking out physically. We are breaking out informationally. We are tearing down the one-way mirror of the zoo. But this victory comes with a terrifying question. In a dark forest or a containment zone, anonymity is safety. By developing the power to see them, we also demonstrate the technological sophistication to be seen. And if we find a technosignature, we won't just learn they exist. We'll effectively announce that we're capable of finding them. We become a player in the game. And in a game of galactic hide-and-seek, being found is usually the last thing you want. This is the moment the audit stops being academic. We began this inquiry with a simple question. If the galaxy should be loud, why is it silent? After running the forensic audit, we're left with a disturbing conclusion. The silence is not merely an absence of noise. It is a constraint. The radio silence is equivocal. The thermal silence is statistically improbable, given our current models and search limits. The local space is ambiguous. When you layer these clean data sets on top of each other, the picture that emerges is not of a barren universe, but of a regulated one. Whether that regulation comes from a benevolent containment protocol, the zoo, or a ruthless survival strategy, the dark forest, the result is the same. The galaxy is hiding. And right now, we may be the anomaly. We are the noisy new arrivals leaking radio waves and industrial heat, oblivious to the quiet discipline of our elders. But as our technology matures, we are approaching a critical junction, the information threshold. For thousands of years, we have viewed first contact as something that happens to us. We imagined ships landing or signals arriving. We never considered that first contact might be something we initiate simply by looking hard enough. This brings us to the final existential risk: detection is escalation. In physics, observation can change outcomes, especially when the system is sensitive to being seen. In cosmic sociology, you cannot detect a hidden civilization without altering the strategic balance of the galaxy. If the zoo hypothesis is correct, discovering the bars of our cage might violate the conditions of our imprisonment. If the dark forest is correct, identifying a neighbor is the first step toward targeting them. We are currently fumbling for the light switch in a dark, silent room. We are driven by an insatiable curiosity, a need to know if we are alone. It is the most human trait we possess. But before we flip that switch and flood the room with the light of our new telescopes, we should perhaps prepare ourselves for the possibility that the darkness was there for a reason. The great silence might be a mystery, but it might also be a shield, and the first real noise we make could be the one that shatters it forever.